Welcome again to the Sec Dairy program. This is the second part of talking about forage. This is John Bonnier talking about forage and forage quality. In this section, we have quality farm mechanization, a little bit about irrigation, and how do we store our conserved foliage. Let's start with quality. Here you see it's best if you want to have baled products, hay, open the bale, pull out a little bit as you see here and see what it looks like. As I said in the previous part, silage from or hay from legumes is much more sensitive because leaves may be lost and we end up with just fiber. What do we look at? We look at the maturity. If we see seed heads, we know mowing was a bit late, a bit too late. If we see flowers and seed pods, we can indicate at least, okay, this was harvested at the right stage. This is what we want. We also look at how is the relation between stems and leaves. If we have too many stems, we know we have a lower quality. Color is another indication. In the picture you see this alfalfa hay, nice and green. It has been harvested in a good way, made hay nicely and stored properly. And this is what we like to see. If the color changes then to brown and black, we know already that it's not what we want. It will be lower. Smell is also important. Nice, fresh smell is what you want, and not this musty or moldy odors that sometimes happen. Overheating is a problem, gives loss of value, and so burnt smell is also not good. You can feel the stiffness, and that means if it's a lot of lignin, it feels more stiff, more hard than a crop which was harvested at an earlier stage. You also want to see if it's clean. If you think you're buying alfalfa hay and 30% is from other weeds with a lower feeding value, you're paying too much for a lower quality. So another thing is that be careful with wire and other things that can end up in the hay, and your cows can by mistake get it inside. Small pieces of wire are very dangerous. Look at the bales, well cared for, not broken, not thrown around, nothing. So all together it will tell you whether it's reasonable quality. This hay we see here, I don't know what you think about the softness, but to me it looks already pretty hard. With silage, we also smell and see and feel to get an understanding of what we are buying. Here, the first thing we see from a distance is the front of the bunker. Is it smooth? And why should it be smooth? This bunker is quite smooth. It can even be better than that, but this is quite good. And that means it is well pressed, so air cannot easily enter. And that we don't want any air coming inside and spoil what we've got. So if air enters, molds and bacteria start their work, which we don't want. In grass silage, we look at protein-rich grass or not. The color is an indication. A dark green always shows that there is protein inside and that it has been fertilized properly. The lower the color, the lighter the green, the less protein you can say. And the fiber, like the other one, if there's too much fiber, it becomes hard and sharp, and it's more difficult to press. The quality will go down, so you don't want that either. Cows like a good taste, and if it smells musty, dusty, and if they're fungi, etc., they don't want to eat. They'll just refuse to eat. So if palatability is reduced, feed intake goes down, and your milk also goes down. In maize silage, we look at the corn. How much kernels are there still in the side, and are they broken? If we harvest at 35% dry matter, the corn is at a pretty hard stage, and then the cover is pretty hard. Cows will not be able to digest much of it if it's not broken. Yeah, so with 28%, this milky stage, there's no problem. It's so soft. What is left can be digested quite easily, but then you have other losses. So we want kernels that are broken, and we want maize that is harvested between 30-35% dry matter. The choplings is also, again, the structure. We talked about structure value when we talked about nutrition. So if we make it too short, there's no structure value. And if we feed a lot of maize silage without structure, and we have a lot of concentrates on top of that, the whole structure value in our ration will not be enough. So harvest it with 35%, use a crusher for the maize, and look at the lignification as a standard for quality. Here we see a picture where it's tight enough. It's grass silage, which is tight. It's pretty dark grass silage, and it's a pretty rough way of cutting. And the rougher it is, the more chance that oxygen will find its way inside and start to make damage. So, in principle, a lot of losses come when in a period of storage. So we have to do that carefully. And when we have aerobics conditions, we get molds, we get yeast, we get heating, we get destruction. So be careful how you do that. This is the molds and mycotoxins that sometimes can be found. It can be very common, and it doesn't start when you make your silage. It starts normally already during the field period, and then continues happily till finally it is fed to the cows. Mycotoxins are not good for humans. It can be found in the milk. Dairies that are serious, they give a penalty if there is any mycotoxins found. So check your feed. Don't give this to the young stock or the dry cows because you say it's not good enough for my milking cows. I'll give it to the other one. It's just not good. And mycotoxin binders can be helpful to reduce the effect and to protect you. The relative feed value, that's something which you sometimes find and which especially used in the marketing business. If you want to have one figure to compare quality, this is practical, and you can go across the market, and if you have the data, you can see what's better. I don't know if you already came across this system or whether you use it, but basically, if you want to compare haze, instead of doing it by the eye, this is a way of doing it. This is the formula of how you estimate it. It's based on the digestible dry matter and the dry matter intake. And in this formula, they come to a figure. In this case, in the example, it's a figure of 164, which is quite high. And if yours is that high, then you're doing quite well. Now, it's not an exact thing. You work in ranges. It's either between 150 and 170, or 130 and 150, or 100, 120. And you say, okay, within this group, it's acceptable. Within this group, it's for me not so good anymore. So let's forget about it. From the quality of our forages, we move to the farm machinery. If you produce your own crops, there's a need for machinery, and you have two choices. Do you use your own machinery, or are there contracting services available to do it for you? Or do you select machinery for part of the work, which is a regular job, and only some things you leave to the contracting company? So you have to find out, and when you make your selection of the equipment, well, how many hectares do you have? What crops do you produce? And what do I have to do to get a good crop? Once you have everything ready, you can start looking for quotations and suppliers and make your choice. I have listed at least the basics for crop production. Field work is one part. So the soil preparation, the sowing itself, the fertilization, either chemical fertilization or manure. And then we have the solid manure, and we have the manure mixed with straws, which needs a spreader. What kind of soil preparations do we have to do? Do we need a corn planter, or do we seed grasses? All this you need, and whether you need a small one or a big one, that is depending again on how much do you have to grow, how many hectares, and what's available. Once the crop is there and we can treat it and put the fertilizer and everything, we come to the stage of harvesting. Well, if we have enough land, we can start with a forage harvester, and then with attachments for either corn or for grains or for silage. We need the different attachments to make the best use of it. We need tippers to collect the chopped product, and then we can take it to the silage pit. We can also say, okay, we, after cutting and wilting, we make the round bales or the square bales. There are also many types of balers these days, either the balers for hay or the balers for silage with wrapping parts with it. So all this is possible. Again, this is the choice. What do you want to do, and how are you going to do it? If you have a forage harvester, you cannot do that with 10 hectares, but you need a large-scale enterprise. And otherwise, you have to find other ways to harvest. For the feeding, it's nice to have a feed mixing wagon. You can put in the different products that you want to have in front of your cows, a mixture of grass and legumes, and maybe sugar beet pulp and a few other things you can mix in, and make sure you get the right balance. You can make sure that you have the right dry matter content in that mix. That's one thing. But you need to get it in, you need a loader again to put it in, and the loader can be used for many other activities as well. Then you have the small tools, the pellet fork, the buckets, the silage fork, the cleaning equipment, cutting the silage, there are many options for that too. And the feed scraper here. This is a scraper. We have also seen the ones with the tires that put the feed in front of the cows again a few times per day, so it looks fresh. For each piece of equipment, you have to pull it with a tractor. Now, tractors, there are many brands, many sizes. The type of machine also determines what type of tractor you need to pull it. And of course, if you have a smaller farm, you need a smaller tractor, and try to find the equipment that can manage all the different activities with the same tractor if possible. But on the larger farms, if you have a feed mixing wagon, it has to go a few times per day. You need it. The scraper has to go several times per day as well. So you may have one tractor just for in the barn and around the barn. And then you have your tractors which can be used for other activities. So you have to see how many do you need and what size do you need. Nowadays, and in the places where I come, growing crops without irrigation is becoming difficult. Here in the picture, this is in Kosovo, where no irrigation was available at the time when this alfalfa was grown, and you see the result. And a field that could be irrigated looks like the one on the right. That's the big difference. So your field work is the same, your harvesting work is the same, and your result is a big, big difference. So when we know that we have to irrigate to get a good crop, then we have to see what forms and what systems of irrigation do we have, and then make your choice. And the last point here is the irrigation water. Water availability is a concern in many, many places nowadays. And if you look at the Middle East, where we do a lot of irrigation, and the groundwater is going down, and there is not enough rain to replace it. So in 20, 30, 40 years, we will have serious problems there and find other solutions on how to get enough water. Even drinking water at times is difficult there. The FAO, they made predictions for the water use, and that depends on the temperature. We have low, medium, and high. And we have the different climatic zones, the semi-arid and the arid zones, subhumid and humid. And then we see the water requirements for a crop millimeter per day. So for the semi-arid high temperatures, we need 8 to 9 millimeter per day in the growing season. Now, we can use surface irrigation. And I when I was young, that was still quite common. We just flooded the field, drained it off, and the crops were quite happy. That meant a lot of water use. Drip irrigation became developed because it's far more economical. You have a drop of water, little by little, and it goes to the roots, and the evaporation is limited very much. So you use less and still has a good effect. And then we have the systems that go in between those two. Here we see the total requirements for different crops. Alfalfa here in the table has a growing period from 100 to 365, depends on how you produce it, but it's a perennial. So in principle, it can be there for 365 days, and that's several years. And then in the growing period, when it's really active, you see the water requirements. Barley, the grains, 120 to 150 days. 3, 4, 5 months, and then between 400 and 600 millimeters. Sorghum, maize, each has its own requirements. It's the total requirements. Then at the beginning stage, you see that the crop is still small and it needs a bit less water. When the crop matures further, the water requirements become higher. So if you develop a system with irrigation, make sure that there is enough water and capacity to cover the needs also when the need is at its highest peak. And then later you can just reduce a little bit. The grains, when you harvest them, they are in the ripening stage and they need less at the end. Green forage will need as much as it needs till the very day of harvesting. Now here we see the simpler systems, the sprinklers for smaller areas. You can connect the pipes quite fast, easy connections, attach it to a water supply system, either from the river with the tractor pumping it or with a small diesel engine pumping it, and then you can reach part of the field, and then and you can also use hoses which have the same way but nipples that spread it, and you can move them around the field till you have everything done what you want to do. The water cannon is a little bit different. It's put in the field, and there is plenty of power, and the water cannon blows the water, say 15 meters or 20 meters even far, and it moves around, so it covers quite a nice area. And under water pressure, then it's rolled back to where you put your tractor and your pumping system. So that's also a way which on grassland, smooth field, is quite attractive and affordable still. In the corner, right corner, I put some water quality criteria. It's if you have groundwater, it's good to have it tested and see what water it is that you're using, because salinity can be a real hazard, and other parts also need to be in line with what water quality demands. So check it before you use it. Well, we mentioned drip irrigation. It's water saving. It's nice and efficient. It was in the beginning mainly used for the more expensive crops in vegetables and crops that are grown on specific rows very much. In maize, it's also meanwhile become common, not so much in Holland, but in France you see a lot of maize growing under irrigation, and I can imagine in many other countries where you have even less water, it becomes necessary. Even in countries like Malaysia, which have a quite warm, humid climate, there are periods when irrigation really helps to get a successful crop. So irrigation is something to keep in mind anywhere, anytime. The last system that we have here is meant for the large-scale operations, and the pivots in the desert. You see those pivots in big circles turning around from one central point, and in other places we also have the linear system, which can be useful if you don't want to lose land, because with the round circles it's more difficult to cover everything, and your land may not be suitable for a round system or a square system. You have to see how is it formed, what are the boundaries like, how can you reach every part you want. This is quite an investment, a system like this. So here there are a number of good suppliers and they can give you all the information you need when you really want to decide for a system like this. Then we will have a few slides about the storage. Round bales of hay. Water content in the bales should be low, less than 60%, and 20% is normally in smaller bales quite good. But if it's not dry enough, we ask for problems. And if you still want to see, okay, this is a little bit wetter than I wanted to, then make sure there is ventilation, that air is flowing, that it's not have a chance to rot and heat. Don't keep your hay outside. Put it under cover. I don't think this hay was stored quite nicely. I like it to be stored properly, stacked, and not more or less thrown in. But at least it is dry. Even the round bales, which look quite tight, don't keep them outside. Also, they should be under a roof. Well, silage, we can avoid losses when in the process of silage making by cutting it at a proper length and filling the silo rapidly. Don't leave it open, and have a silo which is really closed off properly and strong enough, and don't get holes in it. Cutting lengths, well, when I see this picture, this is taken from a farm I visited. This is cut quite long. That's I see pieces that are almost 15 centimeters. It will be very difficult to pack it tight enough to get the air out if it's so long. So chopping length is important. The silage we also want to make at a stage that it's not too wet. 40-45% dry matter is quite nice to have a good grass silage. And also for legumes, 35-40% is needed. And if there's not enough water, on the other hand, then you also create your own problems, because then you have the risk of molds and heat damage. So the balance is quite important to do it rightly. This is the last one about storage and about pressing. Take your time to press well. Make sure you get as much oxygen out of the crop before you close the silo. It makes the fermentation faster and better, and your quality better as well. Cover it properly. Make sure there are no holes. You have to cover it either with sand or tires or something on top that keeps the pressure on the silo. You have seen different pictures of silos, and always there was quite a solid cover that you have to take off bit by bit when you start feeding. We also, what I still want to mention is that if you're feeding your silage, make sure the feeding speed is good. Feed 15-30 centimeters per day to avoid oxygen entering your silo. So let's say 1.5-2 meters per week you have to do. In our chapter on housing, we discuss the silage dimensions and how you can make them. So there you can also look if you want to refresh your mind. Now we've come to the end of this section 3 and to the end of chapter 5. The next one will not be about nutrition, but we will talk about reproduction and breeding as the next chapter.